I'm Melissa Lawson.
And I'm Anna Brooks.
We have looking for and making use of structures. Using the same problem we had last time, there are 20 boys and 15 girls in Miss Mock's first grade class last year. This year, the number of boys decreased by 25%, but the number of girls increased by 20%. Was there a decrease or increase in the overall number of students from the class from last year, and then to find the overall percent of change of the class, what would you do? So if we have 20 boys times 0.25, that's 5 less boys, and then 20 minus 15 girls times 0.2 equals 3 more girls. So then if you have 20 minus 5, 15 boys, and then 15 plus 3 equals 18 girls.
Some students may see this as 20 times 0.25 minus 15 times 0.2. This would give you 2 more students than last year. Some students also may see this as 20 minus 5 plus 15 plus 3 equals 33 students.
So if you have 20 plus 15 equals 35 students from the year before, then 15 plus 18 is 33 students this year.
Some students may see this as 20 plus 15 minus 15 plus 18 equals 2.
For example, the students can tell that with the expression 20 plus 15 minus 15 plus 18 is 2, that the value is going to be more than 0 because it's going to be positive. So if we have 35 minus the 33, so 2 more students last year, and then if we find out the percent, that's 5.7% of change. So if you take the students can see 20 over 35 times x over 100, and then you cross multiply that to get the 5.71% that you need.
The math standard that we had was mathematically proficient students look closely to discern a pattern or a structure. Young students, for example, might notice that 3 and 7 more is the same about 7 and 3 more. Or they may sort a collection of shapes according to how many sides the shapes have. Later, students will see 7 times 8 equals the well-prepared 7 times 5 plus 7 times 3. In preparation for learning about a distributing property, in the expression 2x plus 9x plus 14, older students can see that 14 as 2 times 7 and the 9 as 2 plus 7. They recognize the significance of an existing line in a geometric figure and can use the strategy of drawing an auxiliary line for solving problems. They also can step back from an overview and shift perspective. They can see complicated things, such as some algebraic expressions, as single objects or as being composed of several objects. For example, they can see 5 minus 3, x minus 2, times x minus y times 2 as 5 minus a positive number times a square, and use that to realize that its value cannot be more than 5 for any real numbers x and y.
Okay, so basically a percentage is a rate, number, or amount of each 100. A fraction with a denominator of 100 is called a percentage. Quotient by a percentage sign or divided by 100, the sign is called percent. The term percentage is a short form of a Latin word per curiam, which means out of 100. So basically, if you have a whole, that's 100%. If you have half, that would be 50. If, say you had a pie, you eaten half the pie, then there'll be 50% of a pie left. And a way to teach this to students where if you basically start off with the percentage, start off with a whole, you can get multiplications of a whole, a half, a third, a fourth, to have them learn what each one looks like, and then you could have fraction sheets for them to do. Color in half of a fraction, color in a third, fourth, until they get to a point where they can grasp the concept of the products or of our problems. You could have them work in pairs, in groups. You can do whole class participation while sitting in front of the smartboard with you. There's so many different ways that you could teach this to children. And
some ways that we could incorporate this with the SciOp features is for groupings, we could use small groups or partners, and we could partner kids up and do games that include fractions and turning fractions into percentages. And with games, it would make learning more fun, but also they would be getting the concept of what they're supposed to do.
It's always having hands-on activities is always better than worksheets because they can grasp the concepts a little bit better because they're moving around and not filling out a worksheet. You could also have them, when they're writing, say this is 24%, For the independent working, you could always do assessment for them, that math test at the end of the week to make sure they have grasped the concept, and if they didn't, you can always reteach certain parts of the lesson that they didn't understand fully. You can always model what you're teaching for the kids by having your own paper on the smartboard. Like, okay, we're going to figure out what half of this is. What half of 100 is this one? What's a third of 100 out of this one? Independent practice, you can always send homework home with the kids to decide, so their parents can help them grasp the concept of what you're going over in the class. For EOL learners, it's always good to have a way for them to, so you know that they're getting it, thumbs up, thumbs down. If they don't understand, that is any student, not just EOL students. You can always have like partners and partner up the ELL students with somebody that is higher, so that they can help each other with what they have to do.